previous lecture, so we solved the problems on DC shunt motor. In this lecture, we will solve the problems on DC series motor. A 4-pole DC series motor has 944 wave connected armature conductors. At a certain load, the flux per pole is 34.6 milliweber and the total mechanical torque developed is 209 Newton meter. Calculate the line current taken by the motor and the speed at which it will run with an applied voltage of 500 volts. Total motor resistance is 3 ohms. So, what is the given data? The number of poles are 4 and 944 means Z is equal to 944 and the wave connected means number of parallel paths is equal to 2. The flux per pole is 34.6 into 10 to the power of minus 3 Weber. The mechanical torque is developed total S is equal to 209 Newton meter and line current is how much, speed is how much. If I am having applied voltage is 500, the total motor resistance is given, that is Ra plus Rse is equal to 3 ohms. Now you should draw the diagram of DC series motor. Then you can easily understood. This is armature. The series field winding is connected in series with the armature. The armature resistance is Ra. I am taking a line current is how much, supply voltage is 500. So first you can calculate the EV equal to V minus Ia into Ra plus Rs. So EB is equal to V minus Ia into Ra plus Rs. So in this problem, if you observe, the back EMF is the unknown quantity. We know IA is also unknown quantity. Ra and Rc we know. So how we can calculate? Let us check it. The armature torque is equal to 1.159 into 5Z into Ia into P by A. From this you can calculate Ia. The armature torque is given, that is 209. So 209 is equal to 0.159 into 5 is 34.6 into 10 to the power minus 3. The total number of conductors are 944 and Ia I have to calculate. The wave winding means number of parallel paths are 2. So from this I got it Ia is equal to, so from this I can calculate the Ia value 20.122 amperes. 20.122 amperes. Then substitute in the back EMF equation. EB is equal to 500 minus 20.122 into total circuit resistance is 3. Then so back EMF I got it as 439.634 volts. So then find out the 5Zn by 60 into P by A. Find out the speed by using this equation. 439.634 is equal to flux 34.6 into 10 to the power minus 3 and the number of conductors is 944 into n divided by 60 into 4 divided by 2. If you calculate, the speed of the armature is 403.798 rpm. So for calculation purpose only it is 0.78 like that, but either it will be rotating 403 or 404 like that. So a 4 pole D 250 volts DC series motor as a wave connected armature. So number of poles is 4. The supply voltage is 250 volts and number of parallel paths is 2 wave connected armature, and Z is equal to 1254 conductors. The flux is equal to 22 into 10 to the power minus 3 Weber, and the motor takes line current is 50 amperes. In DC series motor, line current, armature current and series field current, all the currents are same. Iron and friction losses amount to be 1.0 kilowatts. So iron losses and friction losses, okay. So that is called the no load losses. Also we can take it as 1.0 kilowatts. And the armature resistance is zero point 0.2 ohms and the series field resistance is 0.2 ohms. And the first of all calculate the speed. So EB is equal to 5 Zn by 60 into P by A. 5 is 22 into 10 to the power minus 3. Number of conductors are 1254 and speed I don't know, by 60 into poles. What are the poles are 4 by 2. So then EB also, the EB can be calculated like this: V minus IA into RA plus RSC. The no load losses, under no load losses, friction and windage loss is there, and one more loss is also there, that is called the iron losses. You can say that it is a constant losses. So 250 minus IA is 50 into RA plus RSC, 0.2 plus 0.2. So I think you got the answer is 230 volts, that is back EMF. So 230, this is equal to 230. Okay, EB equal to 230. So then the speed I got the answer is 250.1087 RPM. Then the mechanical power developed. So when the mechanical power developed is equal to EB into IA, 230 into 50, that should be equal to 11,500 watts. Then the output power is equal to PM minus iron and friction losses. Yes or no? As we discussed already, PM is called the gross mechanical power output. So gross salary and net salary like that. So if you subtract the iron and friction losses from the mechanical power developed, then you will get the shaft power. So 11,500 minus 1 into 10 to the power of 3. Why? Because iron and friction losses is given as 1.0 kilowatts. 1.0 kilowatts. Then finally I get it as 10,500 watts. So B dot HP is equal to power output is equal to, power output divided by 735.5. So P output is 10,500 divided by 735.5, that is 14.276, that is in terms of BHP. Then the shaft torque power output divided by 2 pi n by 60, 10,500 divided by 2 pi into 250.1087 divided by 60, then 400.8961 Newton meter. power input is equal to V into I. So 250 into 5. So shaft to power, we know that power output divided by 2 pi n by 60. The power output input is equal to supply voltage into line current 250 into 5. Then I got it as 12,500 watts. If you want to calculate the efficiency, as I said, output power divided by input power into 100. The output power I got it as 10,500 divided by 12,500 into 100. Then the percentage efficiency I got it as 84%. And coming to this problem, a 250 volts DC series motor runs at 500 rpm. The shaft torque, that is called the useful torque, is 130 Newton meter. The efficiency at this load, particular load efficiency, is equal to 0.88. Find the current taken by the motor. So power output is equal to, the useful power output is equal to shaft torque into omega 130 into 2 pi n by 60. So where omega is equal to 2 pi n divided by 60, then I got it as 6.8067 kilowatts. So if you want to calculate the power input is equal to power output divided by efficiency. Why? Because efficiency is equal to output power by input power. If I want to calculate the input power is equal to output power divided by efficiency, that is I will get the 6.8067 divided by 0.88, then 7.7349 kilowatts. So from this, power input is equal to V into IL. 7.7349 is equal to, the supply voltage is 250 into line current. So that is our question. So by using calci, you can get it as 30.94 amps.